Hello everyone, we are at Beyond the Formula. Let's continue conic sections with rectangular hyperbola. So far we have seen the equation of hyperbola, that was x squared over a square minus y square over b square equals 1, right? That was the equation of hyperbola, correct? Now rectangular hyperbola. For rectangular hyperbola, it is the special case. It is a special case of what? Regular hyperbola. What happens here is, if length of transverse axis equals to length of conjugate axis, that is A equals B. So the length of transverse axis equals the length of conjugate axis, that is A equals B. So the equation changes to what? X square over a square, say it is a, let it is a. X square over a square minus y square over a square equals 1. That is, we have x square minus y square equals a square. So this is the equation of rectangular hyperbola. This is the equation of rectangular hyperbola, right? Now you see, what are asymptotes? Asymptotes, nothing but these are the tangent line at infinity. What is tangent? Tangent is a line that touches the curve at only one point. So it is a tangent that touches the curve at infinity. This is called what? Asymptotes. So let's find out the asymptotes for this equation. Alright, so we have x square minus y square equals a square. So let y equals mx plus c is the tangent to hyperbola. Let y equals mx plus c is the tangent to hyperbola. Now if this line touches this curve, then this should what? This should satisfy the above equation, right? So let's substitute the value. So we have tangent touching hyperbola, hence satisfies the equation of hyperbola, correct? Now, so we have x square minus y square. Y square will be replaced by mx plus c whole square equals a square, correct? Now let's simplify. So we have x square minus m square x square minus c square plus 2mxc minus a square equals 0. Right, so we have 1 minus m square times x square plus 2mc times x minus a square plus c square equals 0. Alright, so we have a quadratic equation with, say, ax square plus bx plus c equals 0. Alright, we have such quadratic equation. Now for this equation we have what? This point of contact at infinity, right? The line, the asymptote, is touching the curve hyperbola at infinity, right? Now for this equation For this equation we have x or coordinate, x coordinate and y coordinate both approaching infinity, right? Suppose this is the hyperbola and this is the asymptote. So this asymptote will touch the curve at infinity, right? Now for here we have x approaching infinity, right? So for this equation we will have what, two roots, say x equals minus b plus minus root over b square minus 4 times ac over 2a, correct? We have the two roots x1 and x2, say x1 and x2. So for x1 approach infinity, we have a approaching 0, correct? That is the coefficient of x square. And for x2 to be infinity, we have to consider what, x1 to be some fixed value. We have to consider x1 for some fixed value. So if you take x1 at limit a approaching 0, you will get x1 as minus c over b. What you will get? Minus c over b for x2. So for x2, x1 at limit a tends to 0, x1 at limit a approaching 0, you will have what, x1 as minus c over b. So for x2 approaching infinity, you will have x1 as minus c over b, for which implies b should tend to what, 0. B should tend to 0, that is capital B here. B should tends to 0, correct? So here for the curve first root tends to infinity implies a tending to 0, and similarly second root tends to infinity implies b tending to 0. So we have in the equation, look here, in the equation we have this and this as a and b. So we have 1 minus m square equals 0, implies that m square equals 1, implies that m is equals plus minus 1, right? And 2mc equals 0 implies c equals 0, as m cannot be 0. If m is 0, what is m? The slope of the line, which means it is what, x-axis. If m is 0, the line becomes what, y equals c. So it will be a line parallel to what, x-axis, say L1, L2, any line, L2, L3, L4, any line. So this will cut the curve at 2 points, and that will also not equal to infinity. So m cannot be what? M cannot be 0. So what do we have here? M equals plus minus 1 and c equals 0, which gives the asymptote set y equals plus minus x, which are nothing but two straight lines, right, with slope 45 degrees and passing through what, origin. Now you see, if we draw the curve here, we will see such curve. Now this is the rectangular hyperbola with asymptotes at angle 45 degrees, right? Now let's see the let's see the eccentricity of the hyperbola. So we have a square plus b square equals c square, right, from hyperbola. Now substitute a equals b. Substitute a equal b. We get a square plus a square equals c square. So we have 2a square equals c square. 2a square equals c square, that is a by c whole square is a by c is whole square is 1 by 2, or implies that c over a is equals to root 2, which is nothing but eccentricity. So the eccentricity of a rectangular hyperbola is what? Root 2, right? And it is a constant value. Now there is another interesting fact here. If I, this is what? X axis, this is y axis. Now if I rotate its axis, right, this is the transverse axis and this is the conjugate axis, right? This is what? Transverse axis and this is conjugate axis. Now if I rotate these axes with angle 45, now if I rotate these axes with 45 counterclockwise, so what is the shape I will get? I will get such kind of shape. Now the x-axis and y-axis will become the asymptotes, and the two lines y equal to x and y equals to minus x will become the axis. So we will have curve like this, which is another rectangular hyperbola with the equation as x times y equals to c, that is some constant. X times y equals c, that is some constant c square, right? Now, so what we have seen is rectangular hyperbola is nothing but a special case of hyperbola with transverse axis length equals to conjugate axis length, right? And its eccentricity is root 2, which is a very important point, right? So among all the hyperbolas, the rectangular hyperbola is the most symmetric because its asymptotes meet at right angle, right? These two slopes has what? The line say y equal to x has slope what? 1, m1 is 1, and y equals minus x has slope m2 is minus 1, and we know that m1 times m2 equals minus 1 here, which is the condition for two lines to be intersecting at right angles, right, which is this angle, right? Correct. Thanks.